No modern app works in a vacuum. Your SaaS takes payments through Stripe, talks to language models, OpenAI, Gemini, Anthropic, and sends data to a mobile app. All of this runs on an API. In this video, we'll cover how it works, and we'll build our own API to share data with other services, plus connect an external API to bring another service in. This is lesson 5 of the course on launching SaaS applications from scratch. Links to all lessons in the description. My name is Eugene. I've been in development for over 20 years. All my work is on GitHub for free, so you don't start from scratch. Link in the description. Here's our plan for today. We start with theory, what an API is, what a request is made of, which methods exist, what a response looks like. Then practice. We'll take the users module in OneShot, it already has an API context, and go through how it's structured and how to work with it. Third part, we connect Telegram. When a user is created through the API, the administrator gets a notification in a bot about the new registration. Question before we start. Drop a comment. What integration do you want to add to your product first? Payments, AI models, notifications, analytics, or something else? Write it in one word. I'll look through the answers and do a dedicated breakdown of the most popular ones. After this video, you'll understand how to add API functionality to any module in your project. If you're building a SaaS and want it accessible from a mobile app, third-party integration, or automation, you'll know exactly how to do it. Subscribe first. The next lesson on authentication builds directly on the API we're covering today. Leave a like up front. If the video turns out useless, you can take it back at the end. Let's start with the basics. What is an API? API stands for Application Programming Interface. Sounds scary, but the idea is simple. Think of a restaurant. There's a kitchen. That's where everything gets made. You want to eat? You don't walk into the kitchen directly. There's a menu, a list of what you can order. You tell the waiter relays the order to the kitchen prepares it. The waiter brings you the result. What happens inside? Not your concern. API works the same way. The menu is the list of available requests, what you can ask the service to do, or what others can ask of your service. The waiter is the API interface through which you communicate. Your order is the request. What gets delivered is the response with the data. One program tells another, give me the user list, or create a new record. The other runs it and responds with the result. The first one doesn't need to know how the second is built internally. Concrete example, your SaaS accepts payments. You don't process cards yourself. That's complex, expensive, and requires certification. Instead, you call Stripe through the API. Charge $29 from this card. Stripe responds, accepted. Here's the transaction ID. How Stripe works internally? Not your concern. You just accept payments. That's how all integrations in any SaaS work. Emails, one service. Notifications, another service. Your mobile app gets its data through the API too. Same principle everywhere. Any API request is HTTP. The same technology used when you open a page in a browser. We covered that in the second video of this course. Link in the description. The difference is that instead of HTML, the data arrives as JSON. A request has several parts. First is the URL, the address you're calling. For example, in our app, it might be API users. The address tells you which application and which resource you're asking for. Second is the method, what you want to do. There are a few. Get means retrieve data. Post means send data or create something. Put and patch mean update existing data. Delete means remove. This is a universal standard across all APIs. We'll only use get and post, not because the others don't exist, but because they add complexity without real necessity. A get request is just a link. You can open it in a browser and see the response directly. Post lets you send data along with the request. These two methods are enough for basically any SaaS. Third is headers. This is metadata that travels alongside the request. Not the data itself, but a description of what you're sending, who you are, and what you want back. For example, the content type. Application JSON header tells the server the incoming data is JSON. X API key is your key. You're saying, I'm authenticating with this key. Fourth is the request body, only present on post requests. This is the actual data you're sending to the server, what you want to create or change, usually JSON as well. JSON is text in a specific format, curly braces, keys and values separated by colons. For example, a user object with name, email, and role fields. Every programming language can read JSON and produce it. It's the universal language between services. An API response has a status code and a body. Status codes are numbers. 200 means everything is fine. 201 means a record was created. 401 means not authorized. 403 means access denied. 404 means not found. 429 means rate limit exceeded. 500 means server error. These codes are the same across all APIs. You'll see them a few times and remember them. They always come with an error message explaining what went wrong. Most APIs are protected. Not everyone can read data or make changes. The most common protection is exactly what we built in the last video, an API key. It's sent in a header with every request. The server checks the key through the API key filter, which runs before the request reaches the controller. If the key fails, nothing gets through. No logic runs, no actions happen. That's all the theory. Now let's take a real project. OneShot already has a users module. It has 3 contexts: admin, user management in the admin panel, app, profile editing in the dashboard, and API. Programmatic access to user data. That last one is what we'll look at now. Here's what the API context for users can do. Get request to API users returns the full user list. Get request to API users ID returns a single user by ID. Post to API users creates a user. Post to API users ID updates a user's profile. Post to API users ID delete removes a specific user. All of it is protected by the API key filter from the last video. Everything goes through API users. No extra HTTP methods needed. Notice the delete endpoint. It's a post to API users, JSON ID delete, not a delete request. Simpler, and it works from any language and any tool without special configuration. Let's look at how it's built internally. The API users controller extends the module's base controller it inherits from it. Each method does one thing, accepts request parameters, calls the model, returns JSON via OK or fail. Roots are defined in the roots file, grouped under the API key filter. This is the exact pattern for building an API context in any of your modules. Let's test it. Take the key from the last video, send a request to get users. We get the user list. Now, create a user. Send a post request with JSON data. Done. Now update the user. Specify the ID of the one we just created. ID2. Update the name. The name was updated. Now delete user ID2. Success. User deleted. Try sending a request without a key. We get 401, not authorized. The error message tells you exactly what happened. Now here's where it gets interesting. A request came in. A user was created. The response went back. That's it. But what if we want the administrator to get a Telegram notification every time a new user is registered through the API, not having to check the admin panel, getting an instant message? Let's build that right now. Any external service in OneShot connects through a provider. That's the abstraction layer. All the application code says is send a notification without knowing through whom it'll go. In one place it's written, notifications go through Telegram, want to switch to Slack, change one file. The provider pattern was covered in detail in the architecture video. Link to that in the description. The Telegram provider already exists. Let's look at it. Internally, it's a plain request to the Telegram bot API. We need the address to send to, the bot token, the chat ID. That's it. The provider wraps all of this in a single send method that takes the message as a parameter. Now we use it. We want the API to send a Telegram notification whenever a user is created. Here's the task. In the user's API controller, in the create method, after a user is successfully created, call the Telegram provider's send method with a message saying a new user registered. Include their name and email. We send the task and wait for the result. But we need two more things done first. 1. Create a Telegram bot. Open Telegram, search for bot father, send the new bot command, fill out the form, get a token. 2. Get the chat ID to send messages to. Open your bot, send any message, then call the get updates URL, copy the chat ID from the response, go into OneShot settings, fill in the Telegram bot token and the admin chat ID. Now test. Send a post request to create a user. Name John, email johnnyexample.com, set a password. Send the request to the API. A message immediately appears. New user registered, done. 1 request, 2 results. User created in the database through our API. Notification sent to the admin through an external API. Integration with another service. That's exactly how your own API and an external service work together. And this is where the provider pattern's value becomes clear. If you decide to switch from Telegram to Slack, you don't touch any business logic. Just swap the provider that handles the sending. If you want to build your own SaaS with this architecture without figuring it all out alone, I help with development and system design. My contacts are in the description, summary on API. An API is a conversation between two programs. There are different methods. We use 2, get and post. That's more than enough. We add an API to our service to expose our data to other services. We create API keys to verify access. Does this application have permission to use our service? We connect to external services through providers to build integrations and use their capabilities inside our own app. Last question. Does your application plan to have user registration or not? This matters for the next lesson. It's all about user authentication. Links to all videos in the description. See you then.